Welcome to Eureka Math. I'm Mr. Schenkel. This is Module 8. Sorry, let me change that. This is Grade 8, Module 4, Lesson 2 of our pre-algebra class. Let's get started. Okay, today in class we talked about mathematical expressions and whether or not they are linear or nonlinear, and we're going to decide what these are and explain that for you as we go. So let's start with number 1. The sum of a number and 4 times the number. Well, this is where I'm using some of the information from 6th grade where we learned about all these keywords that tell us what to do in these expressions. And the first keyword that I see is sum. That's the answer to an addition problem. So I want the sum of a number, I'm going to call x, and 4 times that number. So I'm going to add x plus 4 times x, which is really just 5x. So there's my expression, x plus 4x, or simplified 5x. And then I have to decide whether it's linear or nonlinear. And I know that since I have a coefficient, the product of a coefficient and a variable, I know that this is linear. And remember, if our variable has an exponent that is either a 0 or a 1, in this case x is raised to the first power because that's just x, then if it's raised to a 0 or a 1, then we know that this is a linear expression, so that's linear. All right, number 2, the product. Well, product means the answer to a multiplication problem. So this is the product of 5 and a number I'll call x. So this is just 5x. And again, it's the same as before, so we know that that is a linear expression. All right, number 3, multiply. That's easy. Multiply 6 and the reciprocal of the quotient. Okay, so I'm going to multiply 6 times the reciprocal of a division problem. That's what quotient is, answer to a division problem. So first I'm going to look at the division problem. That's a number x divided by 7, or x over 7. And then I want the reciprocal of that. So the reciprocal of x over 7 is 7 over x. So now I can multiply and simplify this. This is 42. 6 times 7 is 42 over x. And in order for me to get the x out of the denominator, I would have to change this to 42x to the negative 1, because a negative exponent throws my variable into the denominator. So to work that backwards, I change it back to a negative exponent to put it back in the numerator. So in this case, we have an exponent that is not a 0 and not a 1. It's actually a negative 1, so that makes this nonlinear. That's a nonlinear expression. All right. Number 4. Let's see. We have twice a number, so that's 2x, subtracted from, so I'm going to take that away from something, 4 times a number, 4x, and then added to 15. So all of this, 4x minus 2x in parentheses, and then I'm going to add 15. If we simplify this, 4x minus 2x is 2x plus 15. And now we can check our exponents. X is raised to the first power, so that means this is a linear expression. Number 5, the square of the sum. So first I'm going to find the sum of 6 and a number. So that's 6 plus x, and then I'm going to square that sum. So all of this in parentheses raised to the second power. As soon as I see raised to the second power, I know it's nonlinear. Number 6, the cube of a positive number, x to the third, divided by the square of the same positive number, x squared. Okay, and now because these are exponents, I can that are being divided, I can actually say that x to the third minus 2 is equal to x to the first power, and since it's either x to the 0 or x to the first, I know this is a linear expression. All right, 3 more. No, 6 more. We're exactly halfway done. The sum of 4 consecutive numbers. Well, if the first number is x, the next consecutive number would be x plus 1, and the next one would be my original number x plus 2, and my fourth number would be my original number x plus 3. So we have all of these that we can add. I have 1, 2, 3, 4 x's. So this is equal to 4x plus 1 plus 2 is 3, and 3 plus 3 is 6. 4x plus 6 is my expression. My variable is raised to the first power, so I know that's a linear expression. Number 8. 4 subtracted from the reciprocal of a number. Well, let's say we start with x. Let's say x is our number. In order to get the reciprocal of the number, I'm going to think of x as x over 1. The reciprocal would be 1 over x. That's the reciprocal of the number. And then I'm going to take 4 away from that. 4 subtracted from the reciprocal, so take away 4. And here again we have our x in the denominator, so in order to move that up to the numerator, I have to take the x to the negative 1 power minus 4. So there's my simplified expression, and you can see that we have an exponent that is not 0 or 1, so this is a nonlinear expression. All right, number 9, half of the product, so product means answer to a multiplication problem, of a number multiplied by itself 3 times. Well, a number multiplied by itself 3 times is to the third power, x to the third power. And then we want half of that. So I could either divide by 2, or I could say 1/2 of x cubed. Either way, I have an exponent that is greater than 1, not 0 or 1, and so I know this is a nonlinear expression. All right. Next, number 10. The sum that shows how many pages Maria read if she read 45 pages of a book yesterday, 2/3 of the remaining pages today. Okay, so 45 pages yesterday, plus, it's a sum, so I'm going to add, plus 2/3 of the remaining pages, 2/3 of x. 2/3 x plus 45, or 45 plus 2/3 x. My x is to the first power, so I know this is a linear expression. It's going to create a line if we graphed it. Number 11, an admission fee of $10 plus, so $10 plus an additional $2 per game. $2 times every game, which we'll call x. 10 plus 2x, again, x to the first power, linear. And finally, 5 more than, so it's 5 plus, 4 times a number, 5 more than 4 times a number, and then twice the sum. So 5 more than 4 times a number is 5 plus 4x, and then twice that sum. So all of this multiplied by 2. 2 times the quantity, 5 plus 4x. Using the distributive property, I get 10 plus 8x. X is to the first power, so it's linear. All right, that is lesson 2. I hope that helps. See you again next time.